Assalamu alaikum أصدقائي الطلاب. Welcome to Chemistry Online with Mr. Ahmed Suleiman. Today we are going to study the second lesson of our chapter Oxidation Reduction Reactions, which is oxidation numbers. First, we need to understand what is meant by oxidation numbers and what is the general rule for assigning oxidation number. What is meant by oxidation number? Oxidation number is the positive or negative number assigned to an atom or indicate the degree of oxidation or reduction. Recall what we studied about oxidation and reduction before. We said the element, the ion, the atoms in a molecule, whether this or that, increase the number of oxidation or decrease this number. The number assigned to any of them is the oxidation number. We can say like the charge of each element. For example, if you have an element like Ag in the form of element metal, has no charge, so oxidation number is 0. If it loses one electron, it means it changes into Ag positive 1 because it loses electron plus 1 electron. So the oxidation number is positive 1 at this case. This is the oxidation number. Sometimes positive, sometimes negative. Like chlorine, for example. If you have Cl2, molecule of chlorine gas has 0 charge because it's a molecule. Overall charge of any molecule is 0. If it changes into Cl negative 1, must be 2 because there are 2 here. At this moment it gains electrons, so we have to write here plus an electron for each one. It means 2 electrons here. It gains electrons and it changes into chlorine negative 1 for each chlorine ion. This negative 1 is an oxidation number. So a general rule for this oxidation number is a bonded atom's oxidation number is the charge that would have if the electron in the bond were assigned to the atom or the more electronegativity element. What does it mean? It means if we are talking about a molecule containing partial charge because they are atoms. Remember, we said that before. If you have a molecule containing covalent bonds, not ionic bonds, so the charges are not complete charges but partially charged atoms. So the element like compound XY, the element that has higher electronegativity like Y, for example, has a negative partial charge. The other atom has positive. Recall what we studied about H2O. You remember that? Water molecule. It's a molecule and has covalent bonds here. The oxygen has higher electronegativity than hydrogen, so it attracts the electron toward it strongly, and it has negative charge, negative 2, because it has higher electronegativity. The other atom like hydrogen has electronegativity less than oxygen, so it has a charge positive. But it has positive 1 for each hydrogen because they are 2 hydrogens. The overall charge of hydrogen, the 2 atoms are 2. Positive 2 with negative 2 makes the overall charge of any molecule 0, as we are going to study in the rules afterward. So we have 2 types of compounds here. First, the ionic compounds, which are binary ionic compounds, means has 2 parts. One positive comes first, then the other one is negative. The oxidation number of the atoms equal their ionic charges, as we said. For example, if you have compound of sodium chloride, NaCl, Na has positive 1, as we said before. You remember that? And chlorine has negative 1. These charges are the oxidation numbers. So the oxidation number of the sodium positive 1, the same as it's a charge. So the charge is the same as oxidation number. Also, chlorine has negative 1 charge. It means it has oxidation number negative 1 as well. So the oxidation number is the same as the charge of the ions in an ionic compound. What about molecular compound? If you have a molecular compound, you know no ionic charge is here. So you remember oxygen, we studied that before in the previous lesson. Oxygen is reduced in the water and it's oxidizing agent, remember that? So oxygen is reduced because it has higher electronegativity than hydrogen, as I said. So the bond between them makes the electron shift toward oxygen, and at this moment it has negative 2 charge. Yes, this oxygen number. And hydrogen has positive 1 only, as we said before. This is the example of water molecule. To understand how to deal with any compound, you have to know some rules. Some rules are important to use them to calculate the missing or the unknown oxidation number of an element in a compound. The first rule is related to monatomic ions. If you have an ion and it's monatomic, like Cl, like Br, like Fe, like Cu, and so on, monatomic ion is equal to the magnitude and the sign of the ionic charge, like bromine negative 1, like iron positive 3. So the charge is positive 3, or some ions of iron positive 2, and so on. Copper maybe positive 1, maybe positive 2 sometimes. Here positive 2 or positive 3. Bromine is negative 1 all the time. Chlorine negative 1 all the time, and so on. All of them are called the monatomic ions. So the ion which is monatomic has the charge the same as oxidation number. What about hydrogen? Hydrogen, we know that it's a positive 1 because it has only one electron and it tends to lose it, so it's positive 1. Yes, but it has special case. If the hydrogen, not in an acid or any compound, but in hydrides, if it's in hydrides, like NaH, for example, at this moment only hydrogen is negative 1. Why? Because NaH, the Na here positive 1, so hydrogen must be negative 1, and you saw sodium comes first. Okay, so hydrogen here at this moment in hydrides negative 1. Only this case for hydrogen. Other cases for hydrogen is positive 1 all the time. The third rule is related to oxygen. Oxygen, as you know, has a charge or oxidation number negative 2, except in some compounds called peroxides, like H2O2. This is called hydrogen peroxide. Or sometimes Na2O2, sodium peroxide, and also H2O2. The peroxides, at this moment, oxygen has negative 1, not negative 2. Okay? Rule number 4. The uncombined element, it means if an element in the form of molecule or metal and it's uncombined, it's alone. At this moment, the overall charge is zero. Like metal, for example, like K, or if you are making reaction with iron with something else, copper with something else in the form of metal, any of them, because they are alone, not in a compound, so the overall charge is zero. Don't say positive 1, positive 2, positive 3, and so on. No, it's zero. Why? Because you are reacting the element alone, uncombined. Not only metals but also non-metals, but you know, non-metals in the form of diatomic molecule like N2, Cl2, Br2, N2, O2, and so on. Any of them are uncombined elements. It's a molecule, yes, but in the form of one element, uncombined with other elements. So the overall charge of each is zero as well. Rule number 5. If you have a compound, neutral compound has the summation of position number is zero as well. Like CaCO3, the overall charge is zero for the whole compound. NaNO3, for example, and so on. Okay, the overall charge of any compound is zero as well. The next rule, which is rule number 6, if you have polyatomic ion. Polyatomic ion means like CO3 negative 2, like NO3 negative 1, like SO4 negative 2, and so on. Okay, they are polyatomic ions. We said that before. The summation of oxidation number for this polyatomic is not equal zero like compounds here, but the overall charge of the whole polyatomic ion is the same as its charge. So the overall charge of polyatomic ion is the same as its charge, negative 2 here, negative 1 here, negative 2 here, and so on. This is rule number 6. We will apply these rules for an example here. Let's see this example. What is the oxidation number of each kind of these atoms following ions and compounds like SO2, CO3 negative 2 polyatomic ion, Na2SO4 ionic compounds, NH4 by 2S ammonium sulfide. Let's answer the first one. First, to answer this, you have to remember the rules. You don't need to write these rules as I write here, but just remember them and apply them while answering the question. Look, SO4. First, what about oxygen here? We have 2 oxygen atoms here, and its oxidation number is negative 2 because it's not a special case for peroxide. So it's negative 2. Remember rule 3. So the summation of oxidation number for this compound is 0 because it's a compound, not ionic polyatomic ion. So it's related to rule 5. The overall charge is 0. If you remember these rules, rule 3 and rule 5, you can answer now. Negative 2 for each oxygen, and there are 2 oxygens here, so negative 4. The 2 oxygens are negative 4 charge, the overall charge of oxygen here. What about sulfur? Sulfur, you must have number here to apply rule 5 to make the overall charge 0. How? By making this positive 4. The overall 0 to apply rule 5. So sulfur is positive 4. Let's move to the second example. Let's see the example of CO3 negative 2 polyatomic ion. First, we have oxygen here. The oxygen atom related to rule 3 has negative 2 charge because it's not the special case for oxygen. Rule 3. And you remember last rule, rule 6, it talks about the a polyatomic ion. If the polyatomic ion you have here, it means the overall charge is the same as the charge of the polyatomic, which is -2 here, not 0, rule 6. Let's answer or calculate the oxygen number for carbon. -2 for oxygen times 3, it means -6. What you have to do here to make the overall not 0 but -2, what you have to make here, you have to make it +4 to make the overall charge -2 because it's a polyatomic ion, so the carbon is +4. Let's move to the next example. Here we have sodium sulfate Na2SO4. First rule here is rule 1 related to sodium metal, because it's in compound, so its oxidation number is the same as its charge, so it's +1. And we have to apply rule 3 as well related to oxygen. Oxygen here is not a special case, so it's -2. Also, we have the rule of the overall charge of the compound is 0, so Na +1 times 2 means +2, and -2 times 4 means -8, the overall charge of oxygen here. So what you have to make here for sulfur to make the overall 0, what you have to make here, +6. So +6 is the answer of sulfur after applying all rules we have. Let's move to the next example. You have here in this compound, this example, NH4 by 2S, ammonium sulfide. First you have NH4. It's an polyatomic ion, so it has charge +1. Yes, also we have hydrogen +1 here. Times 4 means +4. What about nitrogen? What we have to make here for nitrogen to make the overall +1 because it's polyatomic ion. So we have to make here -3. So nitrogen is -3 here. What about sulfur? We said that NH4 here +1, but we have 2 NH4 here, so all of NH4 is +2. +1 for each polyatomic ion of ammonium, but there are 2, so it's +2 here. What we have to make here for sulfur to make the overall charge, because it's a compound, so it must be -2 to make the overall charge 0. So sulfur is -2 here. Let's move to this example as well. We have chromium element, it's in uncombined state like this, dull and silver color. If it reacts with potassium and oxidized, it forms a compound called potassium dichromate. This potassium dichromate, which is an orange compound. But if the chromium form a compound called chromium 3 potassium sulfate hydrated like this, it changes into purple color. We need to calculate now the oxidation number of chromium in each of these cases. If it's a chromium in the form of metal, the overall charge is 0 because it's an element. But if it's in a compound like this or like this, what we have to do to calculate the oxidation number of chromium? Look, potassium is +1. It's a metal from 1A. +1 times 2, because there are 2, +2. Oxygen is not a special case here, so times 7 means negative 14. And this is a compound, has overall charge 0. So what we have to make here, or to do here, to make the overall charge 0 for chromium here, look, so you have to make here positive 12. Positive 12 plus 2, positive 14, negative 14, the overall charge is 0. But look, positive 12 for 2 chromium atoms here. Each one has only positive 6. Remember that. So chromium here is positive 6 is oxidation number. What about the other example here? Look, potassium is positive 1, but it's only one potassium atom, so positive 1. Okay. And SO4 is a polyatomic ion and it's negative 2. Negative 2 times 2 because they are 2, negative 4. And this is a compound. Leave water now. We don't need to calculate anything related to this water. It's hydrated compound. But if you have positive 1 and negative 4, negative 4 here, what you have to make here for chromium to make the overall charge 0, because it's a compound, positive 3. So chromium here is positive 3. If you want to calculate sulfur, for example, now we got chromium, which is positive 3. Chromium equal positive 3, not positive 6 like this. Positive 3 for this example. But if you want to calculate sulfur, it's easy. Look, this polyatomic sulfate is negative 2. If you have oxygen negative 2 times 4, negative 8. So what you have to make here for sulfur, to make the overall negative 2 for SO4 only, you have to make it positive 6 to make the overall negative 2. SO4 negative 2 only. If you want to calculate sulfur in this example, now we got the meaning of oxidation number and how to calculate the oxidation number, and this is the end of this lesson 20.2 part 1. Thank you, Shabab.